Hey guys, welcome to my channel. Today we are going to see the chapter Chemical Reaction and Equation. For understanding this chapter, we need to know the difference between chemical change and the physical change. So, chemical change is the change in the composition of matter, but chemical change is the change in the state of matter. Chemical change is irreversible, chemical change is permanent, and also the chemical reaction happens when there is a chemical change. I have an example. If milk turns into a curd, curd doesn't get changed into the milk. This is example for the chemical change because the conversion of curd from the milk is irreversible and also permanent. So the next is physical change. Physical change is just the change which occurs in the state of matter. This change is temporary and also it is a reversible change. So the example is ice and the water. If ice gets heated, water forms, and if water gets freezed, ice forms. So this is a reversible change. Water can turn into ice and ice can also turn into water here. This physical change only takes place when there is a change in temperature, pressure, or state in matter. Okay, so here are some examples, not the examples, but the reactions which I wanted to share with you. There are just 4 reactions. First is calcium carbonate. When we heat calcium carbonate, which is limestone, when we heat limestone, we get calcium oxide and also the carbon dioxide. In this reaction, carbon dioxide gas is released. And also here, calcium chloride. The next one is when calcium chloride reacts with sodium carbonate. When calcium chloride reacts with sodium carbonate, we get calcium carbonate, which is the limestone. Third is when potassium chromate reacts with beryllium sulfate. When potassium chromate reacts with beryllium sulfate, we get precipitated yellow beryllium chromate and potassium sulfate. And the fourth reaction is when zinc reacts with copper sulfate. When zinc reacts with copper sulfate, we get zinc sulfate plus copper. In this zinc sulfate, we get zinc sulfate. In this one, copper sulfate, which was blue in color, after this reaction, it turns white. So these were some reactions, and now let's see some of the definitions. So the first definition is of chemical reaction. Chemical reaction is just a process in which some substances undergo bond breaking, and new substances are formed. New substances are formed from the new bonds. Next, what are reactants? Substances which are taking part in reaction are the reactants. Now, what are the products? Products are the results of chemical or physical reactions. So these were the products. Next is word equation. Word equation is a simple way of representing equation in the form of words. And the chemical equation is a representation of chemical reaction in a condensed form. Condensed form, it means in a short way or by using the symbols and words or letters. Next is writing a chemical equation. How to write a chemical equation? There are some rules of writing chemical equations. Correct formulas first, which is the first rule. Correct formulas of reactant are written at the left side of the equation. Next thing, plus sign is put between two formulas of reactant. And the third rule is the formulas of product are written at the right side of the equation, and if there are more than one equation, then plus sign is put between them. Fourth rule, an arrow is put or drawn between the reactant and a product to show direction in which the reaction or the product is happening. Reaction takes place. So if the gas is released in the reaction, then the upward arrow is shown in front of that symbol of substance. And if the substance is precipitated, then the downwards arrow is shown in front of it. And the fifth rule is about heat. When heat is given to any of the reaction from outside, then it is indicated or denoted by a small triangle which is drawn upon the horizontal arrow. And the sixth point or the sixth rule is when any heat is released or it is given with the reaction or reactant, then the word heat is written after it. So if heat is given from outside for that reaction to happen, then it is denoted by symbol plus small triangle. And if in the reaction product is releasing, means if the heat is released with the product of that reactant, then the word heat is written over there. Next is, in any chemical, if any catalyst, temperature or pressure is used, then this is specifically mentioned above or below the arrow. Next rule is about the special information, which is the special information or name of the reactant are written below the symbol of it or the formula. Next and the last rule of writing the chemical equation is, to make chemical reaction more informative, the physical state of reactant or the product is mentioned there as a subscript. If the substance is solid, then S is written. If it is liquid, then L is written in the bracket as a subscript. If it is aqueous, then AQ is written. If it is gaseous, then G is written as a subscript. Next point is balancing a chemical equation. According to law of conservation of mass, in any reaction, the total mass of reactant, means total mass of any element in a reactant, is same as the total mass of any element in the product. So this was just the law of conservation of mass, which is really going to be helpful, or on this basis, the balancing of the chemical equation is done. So let's see how to do it. Step 1, we have to write that equation from the given word form. After writing in the step 2, after writing the equation, we have to check how many elements are unbalanced or how many atoms are unbalanced among them. In short, to check whether the element is balanced or not. In the third step, we have to do is to balance the elements or the atoms. And in the fourth step, we just have to write the final equation. It is as easy as that. But before I show you the example how to do it, let's see what is the chemical equation. What is the balanced chemical equation? As I told you, it depends upon the law of conservation of masses. You are absolutely correct. The atomic number or the total mass of elements, atomic number of elements in the reactant sites are completely similar, or completely that quantity is similar to the atomic number of the elements in product. So this was just the balanced chemical equation. Now let's see how to balance it. Here we have an example of how to balance the chemical equation stepwise. In the first step, we have written the chemical equation in symbolic form. Like we have 2 hydrogens, 2 sulfurs, 7 oxygens, 2 hydrogens, 1 oxygen at the reactant side. And at the product side, we have 2 hydrogens, 1 sulfur and 4 oxygens. And at the second step, we have to check whether both the sides, reactant and product, are balanced or not. For checking this, how to check this? Just form a table like this, in which we have to write all the elements present in this equation and number of atoms at the reactant side and the number of atoms at the product side. See, for the hydrogen, we don't have to write here any kind of this, just the elements, no atoms here. So we have hydrogen, sulfur and the oxygen in the whole equation. And number of atoms at the reactant side of hydrogen is 2, this 2 hydrogens plus this 2 hydrogen is equals to 4 hydrogens. And sulfur at the reactant side is 2 sulfur. And the oxygen is, here are the 7 oxygens, here is the 1 oxygen. So 8 oxygens. And at the product side, we have 2 hydrogens, 1 sulfur and 4 oxygens, 4 oxygens. So this is a unbalanced equation. This is an unbalanced equation. So for balancing it, we have to form, in the third step, we have to balance it. And for balancing it, we have to form a table kind of like this, in which we just have to write number of hydrogen atoms before and to balance. Means कि इतना balance करने पे perfect हो जाएगा. The equation will get perfect or balanced. In the reactant side and the product side. So initially, at the reactant side, number of hydrogen atoms. So first we are taking the hydrogen. We are making the hydrogen equal at the both sides. So before, hydrogen in the reactant side were 4. See, here we have written the reactant side 4. So in two hydrogen atoms were there in H2, S2O7 and 2 in H2O. So total there were 4. There were 4 and in the product side only 2. H2SO4 in H2SO4. So for balancing it, we need to make the product side 4. We can multiply any number here to get the bigger number, though it may be in any of the side. So we can multiply it by any number to get the bigger number, similar number into double inverted. So if you multiply this 2 hydrogen atoms by 2, then we can get 4. So we multiply 2 and in front of hydrogen we will write 2 and that is also off at the product side. So the final balanced equation look like at the reactant side 2 hydrogen, 2 sulfur, 7 oxygen plus H2O and at the product side 2H2SO4. So how it goes now? We have 2 hydrogen at the reactant side and no, we have 4 at the reactant side and 2 into 4 at the product side and sulfur 2 at the reactant side and 2 into 1 at the 2 into 1 2 at the product side. Next we have oxygen 7 8 at the reactant side and 4 into 2 8 at the product side. So this is really very easy. You just need the practice. And the next point on which we are is types of reaction. So the first type of reaction is combination reaction. For the better understanding, you can just learn as combination reaction A plus B is equals to AB. It means in a combination reaction, 2 reactants get reacted and 1 product is formed. This is just the law or the definition of combination reaction. Let's see some of the examples. So the first example is when ammonia reacts with hydrochloric acid, we get ammonium chloride. And the second one is when magnesium strips are ignited to get oxidized 1, we get the white powder of magnesium oxide. And the third example is when calcium oxide is reacted with water, or simply when calcium oxide is put it in the water or added in the water. When calcium oxide is added in the water, we get calcium hydroxide and heat is released. Now the second type of chemical reaction is decomposition reaction, in which simply one reactant gets decomposed into 2 or more than 2 products. As simple as like that. That was really very simple. One reactant decomposed. When one reactant decomposed to get 2 or more products, the reaction is called as decomposition reaction. There are some examples, let's see. We can also take the example of limestone. When limestone is heated, we get 2 products, which is calcium oxide and carbon dioxide. One reactant and 2 products. One reactant, calcium carbonate. And the 2 products, calcium oxide and carbon dioxide. And the next example which I have is, which the textbook have, is when sugar reacts or when we heat sugar, the carbon is released with water in the gaseous form. When we heat sugar, carbon is released in the gaseous form with water in the gaseous form. So one sugar reactant, 2 products, which is carbon and water, CO2 and HCl in gaseous form. And also the next is when 2 water molecules, means the question was how the water molecules will get separated, how they will get decomposed, how H2O will decompose. So if one reactant H2O gets current, then H, which is hydrogen, and oxygen gets decomposed. 2H2O plus O2 gets decomposed. Decomposed, it means separated. When water gets a current, when we supply current to the water, 2H2O plus 2O2 is released. Okay, and also we have one more example which is really very interesting. When we put bacteria in an organic waste, we get organic manure and a biogas. Isn't it cool? Next type of reaction is displacement reaction. In the kind of displacement reaction, the place of iron is taken by the more big ion. Let me explain. Ion is a charged particle. Okay, so if small ion means less charge, element having less charge is there in the reactant side, and also the element having more charge, then that reactant will take the place of having less ion, less reactivity, less charge. Okay, so there's example. Let's see example. When copper sulfate reacts with iron, we get iron sulfate plus copper, because iron means iron is more charged than copper. So copper sulfate reacts, when it reacts with iron, we get iron sulfate with copper. Okay, so next reaction which we have is double displacement reaction. Double displacement reaction. In this reaction, the ions are exchanged to form a precipitate. Ions are exchanged to form a precipitate. Displacement reaction and double displacement reaction are different. Displacement reaction is done between the ions. Means if the more charged ion taking the place of less charged ion. And in double displacement one, the ions in the reactant exchange to form a precipitate. So example is when potassium chromate reacts with barium sulfate, we get potassium sulfate and barium chromate. One more time. When potassium chromate reacts with barium sulfate, we get barium chromate, precipitated barium chromate, precipitated yellow barium chromate, and potassium sulfate. So, in this kind of double displacement reaction, precipitation is must. So, these were the types of reaction.